Welcome back, everybody. I'm filming this one right after the other one because I want to get it to you. This is probably the most helpful video I'll make for this Kossel 2020 from Folger Tech, the Rev B. The Rev B is important here. For this video, maybe not so much. Maybe this is a good overall video for your Delta printer in general. What I want to talk about today is something that gave me so much headache that I would tell everybody to know this before you even start. And here it is. Once you get a print going, the printer is going to interpret a lot of things, and one thing that is interpreting is all this firmware settings that you put in. And when it prints it out, it doesn't know if the cube that you printed is square. It just knows what it's being told to do. So, that being said, I got this printer going right after everything that I just told you guys. And I started printing the cubes, just like they say you're supposed to, just like I would suggest you do. And I started getting cubes that were problematic, I would say. I have a few here. This one is basically, what I'm going to show you here is what happens with my stock firmware. So we'll go ahead and I will try to hold this up. There we go, a 19.3. That's ugly, huh? Here's another one. Ooh, 19.6. And then we have our Z, which is almost always good for me, give or take a bit. There he is. Oh, there he is, 20 across. The Z I've got going, but I've been told that that's easy. Another thing you can do is do each corner individually to kind of see where you're at on that, and that's going to definitely skew a bit. Of course you can do the corners across too. Anyway, if you don't have a digital caliper, get one. You'll be lost without it, and you'll wonder why you didn't have one sooner once you finally do get it. Definitely a good tool. Unfortunately, this video is going to be a lot of looking at the firmware and trying to explain it to you, but I believe it's going to help everybody quite a bit because if I didn't have this, I didn't have this, this was all trial and error. I've gone through almost an entire roll of PLA to get to this point, and I hope that it was worth it for you guys. So here we go. Your prints aren't square. The prints aren't the right size. What do? In this case, I'm going to tell you exactly what to do. First thing I want to show off is a few anomalies that I was having. So let me find a cube here. Here we go. So this one is, this one's right after a reset. So not only did I have a cube, as we get back out here, that was the wrong size, the wrong scale, on pretty much every axis, save for the Z. The Z is, almost always on for me. That's an easy one to fix with that Z height overall. But I also had a different issue, and I'm hoping I can show this to you. I'm going to try my best. But not only was it not the right scale, but it's not quite square. I don't know how I can show this to you. I don't have a square or a right angle to put this on there, but trust me when I tell you, and here I'll point it out, these corners here are further apart than their opposing corner, than their adjacent corners. So this distance here, and we'll measure it, there's a good way to do it, at its maximum as I rotate the cube just a little bit to get that maximum, 28.2. And then if I go to the other two sets of corners, 27.4. And that's the biggest thing that I had an issue with. And trying to fix that is no simple task. First off, we want to talk about the printer itself. What can we do to make this better? Well, in my previous video I said you need to make sure that these vertical rods are perpendicular to the bed. That's number one. Second, we want to go ahead, I'm going to pan up a bit. Sorry for the mess in this room, it is just a catch-all room. Here we are. This little gap right here on the top, we want this amount here sticking up to be the same all the way around. I don't recommend you go flat, that leaves a bit of an margin for error, but I did 20 millimeters on that all the way around on all four. It's a good place to start. Next, doing those end stops on the top there. I kind of neglected those in the video. The last leveling video, didn't really have time for it. I wish I could do a second one, but when you set it up, maybe I will do it again. When you set it up, you want to go ahead and make sure that those end stops are the same distance from the top to the bottom. Or sorry, from the bottom of this support to their top to start with. And then as you do the leveling, there's a million videos on leveling with those end stops, a million videos on how to adjust things, but I'll let you deal with that on your own. We'll go over a little bit here. So that's a good place to start. Level the bed perpendicular to your supports, the same gaps on the top, and the same distance between the end stops and the top support. Okay, start there. If all that's good and all your other settings are good and you follow the videos, if I missed a spot, let me know. I'll do a filler video. I'm sure I did. I'm kind of talking real fast here and doing videos real quick so that I have time to edit them. But let me know. So, what did I do? What did I do to get to this point? Well, first of all, we had to fix the scale. That's what I've come up with. Once we had the right model being printed, everything was leveled out, we got the wrong scale, we got it skewed, we had to make sure it was the right scale. So I wanted to get as close as I can. We go back over to our firmware, and we go ahead and we find this delta diagonal rod here. This might as well be your scale factor. It's basically a measurement of the center on the smooth rods on your printer from bolt to bolt, the center. But what it can also be is if you put in the right values and you're still getting out of scale prints, making it larger will shrink your prints, making it smaller will enlarge the print in a pretty much linear fashion as it goes. So, you know, I would suggest 1 millimeter steps at a time until you're as close as you can be to whatever scale you're trying to test. Remember, the cubes are 20 millimeters. So I got my cube within that 20 millimeters. And then I said, you know, I better do something bigger. So I started printing these guys. These are a 50 millimeter cylinder that's 1 centimeter across with, and then I upped it to make it 75 millimeters by adding a 1.5 scale in Repetier, just because I wanted it to be a little more accurate. So I was measuring across, and I would take my caliper, and I get this, and I can provide this for you if you like, but a 50 millimeter cylinder is pretty easy to make. So what I would do is and I want to also stress, you see I wrote on there the X, Y, and Z. So before I took it off my bed, I have my towers marked X, Y, and Z, and I would write which side was facing that particular tower so that I didn't lose that. Then I would take this and I would hold it up and I would put one side of the caliper right on the X, and I'd go on the bottom and I'd kind of rotate a little bit to get that 75.1. Excuse me. So not too bad on that one. And just for the heck of it, I'll show you the one that I know is wrong. 75.3 on the Z. And 75.1. This one may be a later one where I got a little bit closer, but regardless of that. Lots of those. I mean, I have a bunch. And this is probably only a quarter of them. I have cubes like you wouldn't believe. And I've been giving them away to everybody that stops by. I mean, there's 10 more on the counter in front of me, along with 5 Marvins. So that's what I went through to get you to this point. So once you have something that you're going to use for scale, the larger the better, because obviously the further out you go, the more that deflection, let's tone that down. The further out you go, the more distortion you're going to get on that print if something's not right. So the further out on the bed you go, you know, once you get out to the 90 millimeter mark or so on the edge of the bed, you know, you're going to have a bigger difference. It goes from 0.1 millimeter for that little cube to 3 millimeters once you're further out, which is why I did that ring in the first place, because the further out we go, you know, the more accurate we should be. So, back to the firmware, the delta diagonal rod, that's your basic scale. Something I missed in the leveling one is that delta radius. The delta radius is a very important number. It determines whether or not you have that concave or convex print. I did that in another video. I believe it's the first or the second one, so go ahead and look at that. It explains it in there. Now, on to the really hard part. You're not going to like this. Here, let me scroll down to show you what I did. So what are you looking at here? Well, you're looking at a bunch of variables. I've defined these variables to be these numbers. Why did I do that? Well, I'm following the pattern that's right below it in this section right here. As you have this section, but your numbers should say sine 60, cosine 60, and so on, all 60s. And what that does, as we switch back over to the printer, is it represents the angle of these vertical supports around the printer. 60, 60, 60 makes 180, therefore 60-degree angle here, 60-degree angle here. All you gotta know is that when you combine the cosine and sine together, they should make a complete arc. And that being said, you would want them to be, you know, complementary. In this case, if we go to our tower 1 in the firmware, tower 1 could be anything. I found out that it's the Y. you know, for mine. When I make an adjustment on it, it adjusts something in the Y direction. So, and then of course the X being tower 2. I don't know why it's that way. That's probably not what they indicate. I believe it's X, Y, Z, 1, 2, 3. But when you make an adjustment to 1, it actually stretches in the other direction. I don't know what it is, but bear with me. I'm going to tell you how it works. So, what I did was, you could put any number in here. Really, you can. Instead of this sine 59, which actually just points up to sine 59 right here. That's all. That's the number I'm putting in there. So you could put whatever you want. You want to make it, but it's just easier to keep with this particular pattern since they set it up that way to begin with. So all I did is I took my calculator, and here we go, C-A-L-C. We go to the calculator, and all I did, expand it to scientific, wait for the time. There it is. We're going to wait a second here. 4 o'clock. All right. So we're going to go ahead and take our calculator. If you don't know how to do it, you view, you go to scientific. We go ahead and we just type in 59, and right here it says sine, and there's that number right there for you. That's how you get it. So you don't have to sit here and try to copy my entire list. So you don't even have to do it this way. You can do something else if you really want. But that's how we got those numbers. And what I did was trial and error. And I mean, really a lot of trial and error on this. And to the point where, as it opens here, I was making charts. And in fact, as we switch over back to the view of the printer here, as I pick up one of my discs, there it is. Look, I wrote it on the bottoms of all those. 59 for tower 1, 61.75. In fact, that's what it's at, so this is probably the most accurate that I've gotten. And then the tower 2, and that's a different setting that I'll tell you doesn't work, and I'll show you where to ignore that. So here's my test log. Oh, goodness. Oh, and I'm getting texted. Boy, everything is blowing up here. So here's what I got. Alright, so this is what I ended up doing. Here's my test values here. And of course, I did a little equation just to figure out what those values were coming out to in that overall equation. And then here's my measurements over here. And this is just one. I reset things, I created new charts, and yeah. All you gotta know is that I spent a lot of time doing this. So what you can do is you can put these values in. I make them in 0.25 increments. So as you can see here, here's 58.25. Don't put a point in there, it screws it all up. So just keep doing that. And you're going to have to do trial and error. And what this is adjusting is it's adjusting that angle very slightly around the print bed. So as we say 59, we're saying basically that one of these isn't perfectly 60 from each other. It's actually 59 degrees off. And then the other one, as we go over to another corner, is 61.7. That's what we're looking at in this equation here. The Z we're going to keep constant down here so that we have a point of reference. We don't need to change all three, just the one. If you wanted to rotate things, you wanted to rotate your tower so your X, Y, and Z was completely off, you might be able to do that here. I haven't done it, but that's where I've been told you can do it if you wanted to line up axes differently. Anyway, take these numbers and you're going to have to play with it. I suggest when you start to make them inverses of each other. Now what does that mean? If this one's 59, this one should be 61. If this one's 58, this one should be 62. Between tower 1 and tower 2, they should be complementary to make a perfect 120 when you start. Don't change the negatives. Change both of these to 60. Change both of these to, to whatever you wanted to do, and just keep it like that and do test prints until you're starting to get something that's a little more round. These are the numbers I found. Everybody's going to be different. This is a total variable in the equation that, depending on how you did it, I'm convinced that my numbers are so far off because I have a bad carriage on one side and I may have bent one of the, or have a bent rod, and I may have done it. So whatever it might be, that's what it is. Some people are lucky. They get up and go, and that's the thing. I get a bunch of people looking at me, scratching their heads going, how did you get an out-of-round print? Mine printed right away, and I don't know. I have no idea. So by making your own variables here, it looks like anywhere between 0.84, 804, all the way up to 0.88. That's the difference of a perfectly round print, So you can play with these numbers, make them complementary, figure out what's going on, keep writing it down. A great man once told us the difference between science and screwing around is whether or not you write it down. Write down your results, make a table, make a big chart, whatever you need to. I had a big piece of paper I was writing all of this down on, and then I started putting it into the spreadsheet like this. And as we can see right here, is it 7.5 or 1.5? Let's go back and take a look. 7.5. So 59 and 7.5. Here it is. Look at that. I am a half a millimeter off at 75 millimeters. That's as close as I was able to get it. I kept going and I kept going, and I could never get it any more than that. So I hate to say it, but you know, that's what it is. It's as close as you're gonna get. That's as close as I was able to get. You could probably do it. If you figure out a better way, tell me. Now here's what didn't work. I found some documentation online that used this, and I hope you can see it. But this variable right here, this delta diagonal rod trim, this doesn't work in our, if you use the stock firmware. It's something that you can add. It's something they're developing. But what that does is it basically allows them to trim so that if one of the diagonal rod lengths is different on one of the arms, that it'll still work and it'll still print and scale. This doesn't work. I spent 3 days messing with this thinking it was when it wasn't. So don't worry about it. It doesn't work on this printer. But that after you have some values that you like, you want to play around with this, these values come out all kinds of crazy too. So be very careful with that. Stick to just changing this one. Leave the delta radius unless you're getting those concave or convex. Go back to the other video I haven't mentioned in there on how to fix that. But that's it. Once you get closer and closer, like I said, I wasted a whole bunch of filament. Hopefully this saves you a bunch more filament than I had to waste, but definitely keep an eye on things and keep changing this and making sure that you're getting closer and closer. When you're as close as you can get, call it there, call it a win. Don't beat yourself up over it like I did. I literally walked away from my printer for a week because I was so upset that I couldn't get a perfect circle out of it. You know, that's not me. I stuck with it. I did all this. I just kept going at it. And I'm printing things like interlocking meshes, interlocking joints that with no support now, and it's just wonderful. And I'll do a follow-up video after this on what I've been able to print, what I haven't been able to print, and just, you know, anything else you might want to talk about, because I think this is my last instructional video. I'm going to do one probably on something that I've seen with my printer. My printer is chewing up one of the nylon wheels, and we're going to fix that. But aside from that, this may be the last time unless somebody else has a suggestion. So thanks for watching. Send the comments, send the questions, email me, whatever you want to do, I'll answer. Thanks, guys.